So parallel compression is something, it kind of causes confusion. If you just walk up to a system utilizing parallel compression, it just looks like you've got more medium temp compressors. So what it does, if you'll notice here, we've got two compressors that are piped in parallel with the medium temp. In parallel, meaning that the line coming from the flash tank vent line comes this way, and then we go one path to the parallel compression suction, the other path through our receiver valve to the medium temp compressor suction. And then they both discharge up to the gas cooler. So in essence, piping wise, they're piped in parallel. They're compressors. So somebody chose the wonderful name parallel compression. What its purpose is we want to deal with flash gas coming off the receiver in a more efficient way. So on a 60-degree day, we're at 750 pounds. And if you'll notice here, I think we have the percentages. There's only 17% of the refrigerant that had to flash off to get it from down to our flash tank pressure. So at 17% flash gas, we're just going to send that straight into the medium temp suction line. Even though we've got 17% of the refrigerant in the flash tank that doesn't go to the cases and do work, CO2 is a much better refrigerant. You're still more efficient than HFC to handle that 17% right into the medium temp. And also, it's not enough flash gas to keep one of the parallel compressors actually running. It would chatter and bang on and off, even with a VFD limiting the frequency to 30 hertz. So in cold ambient, you bought your parallel compressors for nothing because they're not used. However, you still have 100% of your load going to the medium temp, nothing going to parallel. However, in a warm ambient, they are brilliant. So in a warm ambient, we've got 43% of our overall mass flow turning into flash gas that we can't use out at our cases to evaporate, absorb latent heat, and do work for us. That means 43% would be sent to the medium temp. That's bad because there's a better way. You purchased two compressors, pipe them in parallel. So we're going to close that receiver valve and force that load to now go up to your parallel compressors. So now instead of going to your medium temp suction, you'll see that path winds up at the parallel compressor suction inlet. So at that point, we had 57% of our mass flow is liquid. That went out and served our cases. That still needs to return to the medium temp suction. However, 43% of our overall mass flow was able to go to our parallel compressors. The way we get it to do that, there's a set point in our pack controller. The pack controller is wonderful, by the way. You tell it that at a certain percentage of opening for the receiver valve, close and activate parallel compressors. So let's say that was 30%. When we do that on that 100-degree day, we're now servicing that flash gas at roughly 30% better efficiency than we would have on the medium temp. So when this was first introduced, this was back when there was a misconception when Transcritical first came around, maybe 10 years back, that you can't use it in warm climates. It will work in just about any climate. It just becomes inefficient because of the amount of flash gas you have to deal with. So the first step for addressing that was adiabatic condensers. And that's basically, if you're not familiar, it's a condenser coil. It's typically a V coil, and it's vertical, and they'll put a pad that they run water across to basically cool the air that the condenser sees, and it kind of lowers your condensing pressure. And that would let you push a transcritical system further south in warmer ambience and still run efficiently. To get even further south, they came up with parallel compression. It was a really smart idea. And it literally lets you save about 30%, depending on the difference between the parallel compressor set point and your medium temp suction set point. And just food for thought, the set point for the parallel compressors will be flash tank pressure. We typically will float that up. When we close the receiver valve, we'll float the flash tank pressure up about 4 degrees to maximize that savings. So that's what parallel compression does. And on this system, on this unit, it's these two here. When we're operating in parallel compression, we're diverting part of our load over to those compressors.